using the quadratic formula to solve quadratic equations. And these are equations of the form ax squared plus bx plus c equals 0. But be aware, we're actually going to try to solve by completing the square instead first. So this video is mainly about completing the square. Stay tuned for the quadratic formula and solving using the quadratic equations. Okay, so to solve by completing the square, 1, write the equation in the form ax squared plus bx equals k, where a, b, and k are constants. And 2, if a is not equal to 1, divide both sides by a. 3, complete the square for the expression on the left side of the equation, so that we have x squared plus b divided by ax plus quantity v divided by 2a quantity squared equals negative c divided by a plus quantity b divided by 2a quantity squared. Notice that in this case, the complete square is the term that has the parentheses, or quantity b divided by 2a quantity squared. That is our complete square term. So 4, solve the equation by using the square root property. So let's try a few examples in this case. And let me write them over here on the top. So for a, notice we have 0 equals 1x squared plus 6x plus 4. And it really doesn't matter whether your 0 is on the left side or on the right side. Agreed? Okay, but let's realize that y equals ax squared plus bx plus c. The critical values is a, b, and c. So a being the green color, b being the red color, and c is the blue color there. And that is what we call our quadratic equation, right? We're given a quadratic equation which is equal to 0, meaning everything is on one single side. So if you have something on the left side or on the right side that's not equal to 0, pass it to the other side where everything else is. And we're going to make a quick list of a, what a equals, what b equals, and also what c equals. In this case, a equals 1, b equals 6, and c equals 4. Once again, in this case, a equals 1, b equals 6, and c equals 4. So try to make a list to make your life easier. And let's realize that even though my 0 on my original equation was on the right side, you can always flip it to be on the left side. Either would work, okay? Either side would work. Just to be aware. So once again, just let me flip it back to the right side in this case, just to make it more constant with what we have down at the bottom there. So we have 1x squared plus 6x plus 4 equals 0. So we always want to leave it or set it equal to 0. And in this case, to make it a little bit easier, we're going to start getting rid of 4. So now that everything is equal to 0, we're going to get rid of as much as we can to the right side. So minus 4 on both sides. That cancels out on the left side, leaves us 0 minus 4, gives us negative 4 on the right side. So we have 1x squared plus 6x equals negative 4. Okay, so let's get rid of the 1. According to our next step, we're dividing by the a value. In this case, it's a 1. So I'm just showing you the step, even though it's just a 1, so that you see in the future case scenarios, you can already see that you're dividing by the a value, even if it's a 1 in this case, but it's just for reference for this one. 1 divided by 1 cancels out. In other words, you're just left with a 1 again. In other words, just x squared. 6 divided by 1, you're left with just 6. Negative 4 divided by 1, you're left with negative 4 once again on the other side of the equal sign. Okay, so up next, completing the square. So this is our step where we're completing the square. So do look at our note down below where it says b divided by 2a quantity squared, and that is used to make it a complete square. So in other words, we want to be able to factor it into a complete square. If you're wondering what that means, stay tuned and I'll explain in a minute. So in this case, plugging in our completing the square, notice what b and a values are. The v value is 6, the c value is a 4. So we should have 6 divided by 2 times the a value, in this case, a value of 1. So there it is, 6 divided by 2 times 1. Notice there's a 2 automatically for our formula, or due to our formula. So once again, we enter on the right side of our equal sign as well, just as stated in our equation down on step number 3. That is the complete square now. So technically this is what we call the complete square, and it's called a complete square because we're now able to factor this. Okay, so now that we have the completing the square term in, let's realize that we want to factor this. So factoring, we have x squared plus 6x plus, let's realize we can simplify 6 divided by 2 times 1, right? 2 times 1 is just 2. 6 divided by 2 gives us 3. So it gives us 3 squared. Likewise, we can do the same thing on the right side. Notice we simplified, then completing the square term to become just 3 squared. And now we want to square it. 3 squared gives us 9. And finally, we want to be able to factor this. So factoring, we have two sets of parentheses on the left side with an x at the beginning of each one, since it's a complete square. But on the right side, we have negative 4 plus 9. Negative 4 plus 9 gives us positive 5. All right, that works. And of course, in this case, now we're trying to find a multiple that gives us 9, and when added, it'll give us 6. So 3 times 3 gives us 9, and 3 plus 3 gives us 6. So 3 would be our common multiple that we need for our factor. There it is. Notice that it's replaced, or it's replicated twice. So that means it's there 2 times. So we can convert it into a single one by saying it's a square. So x plus 3 squared. And this is the reason why we call it a complete in the square formula. It's now a complete square, x plus 3 quantity squared. That's the squared portion. Notice we have 5 on the right side. So now let's get rid of the square by doing the square root, opposite of square, right? And what we do to one side, must do to the other side. So square rooting on both sides. Notice that the square and the square root cancel each other out. And here it's up to you whether you want to leave it an exact value. So square root of 5, you would leave it as exactly square root of 5. But do remember your plus or minus, you need a plus or minus. Or you can convert it to a decimal, agreed? So for my case, I'll convert it to a decimal, so that it makes it easier to follow, for this particular case at least. And let's realize we still have the 3 left on the left side. So we want to get rid of the 3 to completely solve for x. So move to the right side by subtracting it. So minus 3 to both sides. There we go. Okay, so now that we've gotten rid of the 3, combining it, okay, negative 3 plus or minus 2.24, agreed? Notice I just shifted the location of the 3, but it's still subtracting on the right side. Now do realize the plus or minus implies I have 2 possible answers. So I can go x equals negative 3 plus 2.24, and I can also go x equals negative 3 minus 2.24. So notice that 2.24 can either be positive or negative. And now to simplify that, negative 3 plus 2.24, of course in this case gives us negative 0.76, and negative 3 minus 2.24, they're both negative, so the quantities add, so we get negative 5.24. And there is technically our answer for this particular example. X equals negative 0.76 and x equals negative 5.24. Real quick, I'm just going to show a real quick reference as to what you get on your calculator. So let me turn on my calculator real quick since it went off. And what we're doing here is we're going for the y equals button. So y equals, let me clear whatever I have in this case. So this here. And I'm going to enter 1. So we have 1x squared, just so you can see it for reference, 1x squared plus 6x plus 4. And essentially I'm going to go to zoom and do zoom standard, option number 6. So I'll push the button number 6, and there it is. What we've solved for in this case is the intercepts, the x and y intercepts. So if I hit trace and I go down pretty close, right or left, I go down pretty close to my intercept, I get negative 0.85, roughly negative 0.76 is what we got. Go to the other one, just manually moving it for now. I should get negative 5 point something, so negative 5.31, definitely. So if I put the x value in now as negative, keep in mind you got to use that negative sign at the bottom. So negative sign at the bottom of your calculator. And we're going to enter 0.76. And now as you hit enter in your calculator, it should give you fairly close to 0. So there it is. It's kind of close to 0, but keep in mind, we rounded. Hence the reason why we get something approximate. So if I do the same thing with negative 5.24, I should also be able to see that it's close to 0 here, or my x-intercept. So we solve for the x-intercepts in this case. Continuing on, let's go to the next problem. So next problem, B. In this case, we have 5x squared minus 10x plus 45 equals 0. Once again, I recommend you make a list. A equals, B equals, and C equals. Okay, so A equals, in this case, 5, B equals negative 10, and C equals 45. Great. That means, well, we can get rid of the 45 now, okay? That way we can solve by completing the square. Once again, we're not at quadratic equations just yet. We haven't done them yet, or quadratic formula, I should say. So getting rid of negative 45 for both sides. Okay, that makes it so that we have 5x squared minus 10x equals negative 45. All right, now we want to divide by 5. According to our step number 2, divide by 5 on both sides. Well, keep in mind, you got to divide everything by 5. I recommend it individually. It makes your life easier in many cases. So 5 divided by 5 cancels out or gives you 1. Negative 10 divided by 5 gives us negative 2. Negative 45 divided by 5 will give us negative 9. And there's our simplified form of it. X squared minus 2x equals negative 9. All right, now it's time to complete the square. So entering the completing the square, step number 3. So keep in mind, B and A values are from our list that we made previously. So once again, there's our B value, which in this case is negative 10, and divided by 2 times our A value. A value turned out to be 5. And let's repeat it on the other side, negative 10 divided by 2 times 5. All right, so now do realize that, once again, those are my two terms that are what makes this a complete square. So let's simplify them. Negative 10 divided by 2 times 5. 2 times 5 is 10. 10 divided by 10 gives us 1. And then negative divided by positive, still a negative. So in a sense, we get a negative 1 squared. So our formula so far, x squared minus 2x plus minus 1's quantity squared, right? So be careful on that one. Once we square it, we get a positive, agreed? So it's just a positive 1. So x squared minus 2x plus 1 equals negative 9 plus 1. Now let's simplify the right side. Negative 9 plus 1, negative 8. And now we can factor it. Do notice, our complete square in this case has a negative sign. So that implies that we're going to have to use a negative. So negative 1. 1 times 1 is 1, and 1 plus 1 gives us, or pardon me, negative 1 minus 1 gives us negative 2 for our previous form of the equation. Okay, so there is almost our complete square. I just got to realize that it repeats twice, so I can make it a quantity square. So x minus 1 quantity squared, or parentheses x minus 1, close your parentheses, and then a square. That is once again our complete square. Let's get rid of the square by square rooting, and what we do to one side, we must do to the other. Here it becomes tricky because we have a square root of a negative number. Probably before you would say, whoop, can't do it. Let's call it imaginary, well, not real results, I should say. But now let's call it imaginary value by using the I, the imaginary portion, or imaginary number I. Okay, let's realize that the square root and the square cancel each other out. And in the next step, I'll split this up. So we have left x minus 1 equals the square root of negative 8, splitting the square root of negative 8. On the side note over here, negative 1 times 8 is the same thing as getting negative 8, right? But in the radicand, so square root of negative 1 times 8. And let's split up into two radicands. So now there's square root of negative 1 times the square root of 8. The square root of negative 1 becomes the variable, or the number I should say. And the square root of a is still there. We still need the square root of a on there, okay? Unless we want to give it a decimal format. So, which would totally be okay. There is our decimal approximation. So you can leave it as an exact square root of 8 or round it in this case, which I have as a 2.83. Do notice your I, the I value typically goes after the number. So our equation now looks like x minus 1 equals plus or minus 2.83 I. And now let's solve for x by getting rid of the 1. So plus 1 to both sides. There we go, plus 1 on both sides. And let's remember that first portion where we have plus or minus 2.83i, that's an imaginary portion of our formula or answer. So we can't combine it. So technically I'll just put the 1 in front of it. So I have 1 plus or minus 2.83i, and here I can basically split up into two answers, 1 plus 2.83i, and the other one 1 minus 2.83i, but it would do me no good, since I cannot combine the 1 with that number because it has an I on there. So in other words, that is technically our final answer for this one. Now that we completed our answer in this case for both examples, well, let me just talk real briefly and state this. Completing the square can be tedious when solving for a quadratic equation, but we can develop a much more useful formula. So keep in mind, we just solved using the completing the square. But in reality, this can be done much easier, well, significantly easier, I should say, by comparison to how we did right now, by using the quadratic formula. So we use the quadratic formula, x equals negative v plus or minus the square root of v squared minus 4a times c, all of it divided by 2a. This is our quadratic formula. But for reference, I'll talk about that in a different video. So in this case, this is sort of a combination, but mainly completing the square is the main topic in this video.